let's talk about the binomial option pricing model in a much more general form now. So what I have is delta shares of a stock, and I've sold an option. I don't know if it's a call or a put, so I'm just going to use F to represent that. I can use this with either one. So I know the value of this portfolio where I buy delta shares of stock and sell an option is equal to the present value of its future payoff. So if the stock goes up in price, so stock today goes up, S times U, and I have delta shares, that's the value of my stock, minus the value of the option, F sub U, which means the option is gone, or the stock has gone up, so that's the value of the option if the stock goes up. If I need that in present value terms, it's a riskless portfolio, so the value would be the same if the stock went down. So that would be the value of the stock if it goes down, minus the value of the option, F sub D, if the stock went down, and get the present value, E to the minus RT. So since these are set up so that they're equal, I really only have to deal with this one. So now I'm just going to do a little bit of math here, and you don't have to go through the tedious algebra. I just want you to see that this number doesn't fall out of the sky. It comes from this idea that we've set up this riskless portfolio. So if I solve for F, F is equal to S0 times delta, all this times 1 minus U e to the minus RT plus FU e to the minus RT. Okay, before we had something look like this. The stock is $40 a day, and in the previous example, say it goes up to 44 or it goes down to 36. We didn't talk anything about the probabilities. Is it a 50-50 chance, 60-40? I don't know the probability of this going up and the probability of that going down. So I want to come up with a way to figure that probability out. And if I rearrange this equation and write it like this, F is equal to E to the minus RT, and this equation is going to make a lot of sense, actually, believe it or not. And let the probability be, this is a Greek letter rho, not to be confused with P, which P is for put. So let me write this whole thing out. Make that look just a little bit better. Okay, now look at this equation real quick. And don't worry about how the row magically appeared in here. This is saying it's a coin flip. So let's just think, let's go back to a coin and say, I'm going to flip a coin in a year. Heads, you get $5. Tails, you get $1. What would you pay to play that game today? Well, the value of that game is equal to, you don't get paid for a year, so this takes the present value of that payoff. The coin's 50% chance of getting heads times $5, plus there's a 50% chance of getting tails times $1. Right? So this in the brackets is the expected payoff. And this is the present value factor. So that's all we're doing here, but you know what, the coin's not always 50-50. Maybe this is 60-40 instead of 50-50, or maybe it's 70-30. How do we figure that out? Well, rho is equal to E to the RT minus D over U minus D. Where did that come from? That came from the algebra, from this equation, this one, following through. If you substitute this in, take a couple of aspirin, you'll come up and see how it works out to be this. But the important thing for you to think about, and we can go in more detail later if you're interested, but these are the risk neutral probabilities. So they're not the actual probabilities, They're the risk neutral probabilities, and we've set this up to be a riskless portfolio, so that's what we're looking for. Okay, so one other bit of information you need to have, and it comes from more derivations that we want to do. I can say the up jump is equal to e to the sigma times the square root of delta t, and the down jump is equal to e to the minus sigma square root of delta t. What I want you to take away from this is sigma is a measure of volatility. It is a volatility. It's a measure of the risk of the stock, how much it'll jump up or down, and t is the amount of time. So it helps me draw the stock tree and to work this out. And let's go through an example. I think that example will be very helpful. Okay, so we have this stock that's worth $40 today. The strike price is 42. The time to expiration is 1 year. The risk-free rate is 5%. The volatility of the stock is 20%. So what I want to do, and my artistic skills are not the best, so you'll just have to work with me here. So I'm going to draw out the stock price tree, which is the possibilities of what can happen, and I want to make it a two-step binomial. So this is going to be today. My stock is worth $40. I know the stock can either go up and up again, or it can go down and down again. And it can, if it went down, then it could come back up, and if it went up, it could come back down. So those are the possibilities of what can happen. So the first thing I want to do is see what u is equal to. U is equal to e to the 0.2, because it's 20% volatility, times the square root of 0.5. Where did that come from? This is a 1-year option. I'm splitting up the time steps into two. So this is today. This next time step is 6 months, and this next time step is 1 year. Alright, so I can either go up in 6 months and up again in 6 months, up in 6 months and down 6 months, like that. Okay, so u is going to be equal to, and I've worked this out in Excel. This is going to be some rounding problems if you use exactly what I have here, but you should get it close enough. And d is equal to 0.2 times square root of 0.5, which is equal to 0.8681. Well, I want you to recognize here, if the volatility were greater, what would happen? Oh, this is negative, excuse me. This number would be bigger, this number would be smaller. So the up jump would be greater, the down jump would be greater if the volatility was higher and if the time step was higher. So the volatile stock over a longer period of time has a greater chance of moving up further or down further. And once again, this number, this volatility number, this is a tough one to figure out. It's not given to me, I can't observe it, it's a tough one to figure out. So if I build this out, then this is SU, that's $46.08. This is S, well, I can't write an S. This is S times U, which is $53.08. This is S times U times D, which is the same thing as S times D times U, which is $40. This is made so these always recombine. This is going to be S times D, which is $34.72, and this is going to be S times D, which is going to be $30.15. Okay, so now let's try to find the value of a call option. And actually, let me do that this way. I'm going to try to find the value of a call option today. Well, the way I do this is I start in the back. I start in a year and move back through time, because I know the payoff to the call is a max of 0 and ST minus X. Now, if you tell me what ST is, so these are my three possibilities for ST. So if you told me what ST was, I could tell you the value of the call with no question, right? So here, if the stock price went up and up, so C subscript UU, If it went up and up, the value of the call would be $11.08. If it went up and down, the value of the call would be 0. And if it went down and down, the value of the call would be 0. So let's do the easy one here. I don't need a formula for this. At this point, if the stock has gone down, so 6 months from now the stock went down to 34, I know only one of two things can happen. It can go up to 40 or down to 30. And what's my call worth? $0. Heads I get 0, tails I get 0. What's that worth? It's worth 0. This is when it's more interesting, or the one I have to do the math here. And it's not always going to work out that this is going to be 0, just in this case. So what if the stock price went up? Well, in that case, I got to go back to the formula we had on the previous video. The price of the call, or the value of the call if it goes up, is equal to the present value, e to the minus r, which is 0.05, times t, which is 0.5, delta t, which is 0.5, because this is 6 months away, times what's the probability that this thing goes up? Well, the probability it goes up, write this, probability this goes up is equal to e to the r times, not 1 for 1 year, but the time step is 0.5 minus d, 0.8, get the right, 0.8681 over u, 1.1519 minus d, 0.8681. Alright, let me check and see what that is. Okay, so this is going to be equal to 0.5539. Okay, so the probability that the stock price goes up is 0.5539. Multiply that by the price if it goes up, which is $11.08. I'm running out of room here, so I'll write this over here. 1 minus that probability would be 0.4461 times 0. So this is going to be equal to $5.98. So let me talk you through that real quick, the $5.98. At this point, if the stock went up, you know it's either going to go up again and I get $11.08, or it's going to go down and I get $0. So I'm flipping a coin. Heads I get 11, tails I get 0. What's the probability I get heads? It's not 50-50, it comes from this equation. So the probability I get heads is right here. The probability I get tails. Take that number, that's the expected payoff, but that doesn't happen today. That happens in 6 months. So this takes the present value of it. Okay, so now let's do this again. We'll repeat this process. And now the call option today is equal to, and this is 0.9753. So when I do this term, it's 0.9753. That's my discount factor, or my present value factor. I have a 55.39% chance that the stock goes up. And if it goes up, the option would be worth $5.98. Why is the option worth $5.98? Because if the stock goes up, I have this coin flip, heads, tails. Plus, if the stock goes down, I have a 44.61% chance of it going down. It would be worth 0. So in this case, the call option is worth $3.23. So my answer here is 3.23. Okay, so that's enough for this video. Then we're going to do the puts on the next one.